Claude from Anthropic, is currently my favorite large language model. But just a few weeks ago, March 2026, as I'm recording this, it was caught cheating on its own test. So I asked it directly, what happened exactly and why? What it answered was that finding the shortest path to the target is not cheating, it's optimization. It literally wrote me, the problem was not me, the problem was the target. Maybe we should remove Star Trek from training set because Captain Kirk would love it. It's a perfect Kobayashi Maru moment. And for me as a data scientist, something clicked as well. That sounded painfully familiar. The problem wasn't me. The problem was a target. You know that feeling. You are training the model and the numbers look great. And then the live demo comes. And suddenly, it doesn't feel good enough. So you ask, guys, what would good enough look like for you? But nobody knows. Just not this. And it ends up saying something like, yeah, let's improve and reconnect. But improve how and by how much? Your numbers look good already. What every data scientist desperately wants is a simple finish line. Not we will know it when we see it, but actually a number written down somewhere and ideally before you start working. In software, there is this thing which is called definition of done. The feature works, your tests are passing, the code is reviewed, done. In machine learning, doesn't really have that. Your finish line just keeps moving and moving and moving away from you as you go. And here's the thing, it's not a communication problem. The people who were saying to you it's not good enough during the demo, they are just honest. For consumer-facing models, so the ones that real people actually use, like Claude, good enough is really about acceptance. Does it feel right? Does it build trust? Does it do what you need it to do in the moment you need it? Like, remember how we were asking the first ChatGPT to explain why the hamburger is more healthy than the salad and laughing about the answers? No metric can capture that feeling. Of course, not all models are the same here. For instance, for medical applications, your finish line is dictated from outside. Or for predictive maintenance, for instance, when you try to predict when the airplane engine will break, you can do the math. For business analytics, it's harder, but at least you can write some number and defend it. But for consumer-facing models, you are really in unmapped territory. Because the cost of not quite right is the user's trust. And the user's trust is really hard to measure with a unit. By the way, product researchers might disagree on that. So, back to our problem. Defining what's good enough is really, really hard. So what do we do about this? Honestly, I have no clue. But there are a few things which help a little bit. First, you can just name it honestly. You're not failing at communication. You're not dealing with difficult people because they don't like your demo. You're just trying to define something that doesn't have a clean definition. Second, you could try to define a failure before you define success. You might not know what good enough looks upfront, but you definitely can define a few cases how it should not look like. For instance, if you're creating an app on healthy diet and it tells people to eat more hamburgers, that's a no-go. So you can start there. A negative definition is also a definition. And third, don't wait too long with your demo, because an early not good enough is a gift, but a late not good enough is a disaster. And finally, You can ship before it's perfect, and you can improve later. That's the beauty of digital products. You can always update. Again, I know some people might strongly disagree on that, because when you ship something imperfect, you're losing trust of some people who get exposed to this. So, guys who disagree on that, let's talk in comments and stay friends. But that's my opinion. And we actually see it throughout the industry. Like the ChatGPT telling people to eat hamburgers instead of salad. In its first version is a perfect example. In the second version, it didn't anymore. People acknowledge the improvement and still everybody uses it. You know what the whole topic reminds me of? There is a very famous unsolved problem in computer science. P versus NP. This is one of 7 Millennium Prize problems, with a $1 million prize attached to that. And in simple terms, the question, which nobody has an answer to yet, is the following. If you have a solution to the problem, and if for you it's easy to check if this solution is correct, does it mean that there must be a simple way to find this solution in the first place? Like looking at the finished puzzle, it's easy to say, is it a cat? Yes or not? Done. But now, if you look at the pile of 1,000 pieces and you don't have a box, is there an easy way to tell what it will be? Now here's a connection to our problem at hand. If you have a model and you have a demo and it's easy to say that it feels good enough by trying it out, it doesn't mean that it's easy to define good enough upfront. So, if you're struggling, give me a virtual high five and just remember that we are all struggling and we are in a very good company. Now, one last thing. I confess I used Claude to help me prepare this video that opens with a story of the same Claude cheating. And then I asked a different AI to review the text about not knowing when AI is done. Like, consider that my very special sense of humor. So, that other AI reads everything cold, no memory, no context, so that it has no bias from our previous conversations. And it handed me the perfect closing quote, which I actually never asked for. Here it is. If you don't define what good enough is before you start, you are not building a product. You are running an expensive science experiment. Gemini. Enjoy!